implicit differentiation to find the second derivative. Okay. So take this first example and just do the first derivative. Okay, so take dy, or sorry, dx of both sides. Okay, so every time, again, we come up with a variable that is not x, we have to add on the dy dx. So we have 2y dy dx plus 2 dy dx on the right side. So because this is the same variable, right, we have just 2. And then that will be a plus 0, right? We don't need to put the plus 0, but I'll put it in there. So what will be the next step?
Factor out your dy dx.
Okay, so I can factor out the dy dx, and I get 2y plus 2 equals 2. Right, I would absolutely simplify here because I have 2 in everything. I would just divide everything by 2, but I'll do that in just a minute. So I have dy dx equals 1 over y plus 1. Okay. Now, we need to take that result to find the second derivative. Okay, so basically we take that previous result and continue.
Just derive it again.
Derive it again. So continue from that. Okay, so you could either do quotient rule, or you could do y plus 1 to the negative 1. So if you like using the power rule, that's fine. So you want to do that way?
Yeah.
Okay, great. So we have negative, and then y plus 1 to the negative 1. Now, don't forget, this is the important part. Take the derivative of the inside. We have to
Yeah, why is it negative? Why is it negative? Okay.
2.
To bring it from the bottom. We already got.
Okay, so you got it. So we're moving the negative 1 to the front, y plus 1, subtract 1 from the exponent, so you get to the negative 2. Now, I have to apply the chain rule, right? Because I have an inside and an outside. The derivative of the inside would be
Where's the inside of
the inside.
that? So if you do the quotient rule, then you wouldn't have to do it.
Well, you still have to add on the dy dx part, but you're correct in that if you did the quotient rule, you wouldn't have to worry about the inside-outside rule.
Okay.
Okay, do you understand why the dy dx
No.
is there?
No.
Okay, look at what's inside. It's y plus 1.
So we're fine.
So if I had to find just d dx of y plus 1, what would that be equal to?
I see it.
It would be dy dx plus 0.
Yeah. That's it.
Well, that's it. Do I really need the plus 0? So that's how we got that. Now, we're almost done. Well, I can't leave dy dx on the right side.
No.
What was dy dx? Wasn't it here? Or this? So I'm going to substitute in y plus 1 to the negative 1 because that was my first derivative. So we substitute back in our result that we got originally. And then it's just a matter of combining. So this is really a y plus 1 to the negative 3, right? Adding exponents. And finally, I'm just going to rewrite it so that it's in proper form, which will be negative 1 over y plus 1 to the third. Okay.